very much for joining us here tonight at Awin. I'm James Bentley. I work on strategy here at Awin, and I also work on AI projects as well. So I'm just minimizing something. There we go. That's better. It's always the audio visual setup stuff. Anyway, yeah, so Awin, I appreciate. How many of you have heard of Awin before? JP, that's not fair. I told you about Awin like 5 minutes ago. Okay, but thank you, I appreciate it. So Awin, just put simply, we are a great company. We're a leading global affiliate marketing partnership platform. We enable brands to partner with owners of media, influencers, integrated technologies to drive mutual growth. We were founded over 2 decades ago. We have over 1,300 people located in offices across 16 different countries. And we are a pay-per-sale marketing platform where brands pay partners a commission for driving sales. Everyone is like, why are we getting a sales pitch? Don't worry, this is relevant. And I do have another presentation I'm going to go into in 2 seconds. So, yep, we work with 30,000 global brands. We also work with 250,000 click and sale active partners. And in case you aren't familiar with the affiliate model, I'll just give you a quick view of what it looks like. Here's a quick example. So this is an example of the sports brand that is partnered with an influencer. They're running a live stream with an integrated product overlay. Customer watches the live stream, clicks on a product they like. They go through to the retailer's site. They buy something. They earn a commission on that. Awin handles the tracking of all of this and the payment of the commission to the partner as well. Yeah, and beyond influencers, people can partner with media owners, email partners, loyalty partners, and we also have integrated technology partners as well, like on-site personalization engines. And one of our big USPs is that we do all of this in a single platform where brands can find partners and integrated technologies and track their success. Brands like Samsung, who are using one of our technology partners, and they saw a 44% boost in sales as a result of that. And our tech partners are attracting quite a lot of attention. There have been some big acquisitions. Probably the biggest in our industry was Honey recently, who acquired for $4 billion by PayPal in 2019. And we're also super excited about the future of generative AI, no-code solutions, coding assistants. And if you look at some of the numbers on GitHub, more and more developers and hobbyists are working on AI and ML projects, and we hope this is going to bring more growth into our channel as well as we see more technology companies coming to work with us. And yeah, so if you are building technology or if you'd like to join us as a brand or partner, check out awin.com. We've got cool stuff. So we have product feeds and you can build stuff with them. So it's kind of like Kaggle. Has anyone heard of Kaggle before? Right, yeah, lots of nods, right? So we have product feeds. So, you know, you go on Kaggle and you see the Amazon feeds. We've got those, but we've got those updated daily for thousands of retailers. You can come join us and you can start to play with those product feeds. And if you build something cool and people engage with them, you know, you might make a commission on it. And yeah, careers. We're also hiring people across loads of different roles. And we got some great benefits. Get ready for this. We work a 4-day week. Yes, well, yeah, pretty cool. How pretty cool. So, yeah, we also support remote working. We're ambitious, and like I said, we are generally a really great company. So that's Awin, and oh, I like it when it does that. Okay, cool. So that was the beginning bit. Sorry, this is the bit I came to talk to you all about, zero to code. So yes, I'm James from Awin, and I'm here to share my story of how I learned to build stuff in Python with GPT-4 as my coding assistant. Some of you may recognize the title of this presentation. It's Zero to Code. It's an homage to Blake Masterson and Peter Thiel's book, 0 to 1, one of the most influential books in startup culture. Peter Thiel is obviously a legendary venture capitalist. He helped found PayPal. It's worth $7.5 billion. I'm not worth $7.5 billion. This presentation won't make you rich either. Or will it? No, it probably won't, but here are a few more disclaimers as well. All opinions in this presentation are my own. I'm not a trained coder or developer, and you probably won't learn anything, but we'll see how it goes. So, yeah, I'm James. It's the 3rd time I've said that. I'm a dad. I'm also a strategy director here at Awin, working on AI projects. I also worked for Adobe for 6 years. I'll come back to that in a minute. And yes, I am one of those, I'm a self-confessed generative AI wave surfer. This chart here shows mentions of AI on company earnings calls over the past 20 years. That spike at the end, can everyone see that spike? That's me endlessly talking to all my friends about AI. I've been pretty obsessed with AI for the past year, but I've been doing more than just talking about it. I've also got stuck in, and I've tried to learn as much as I can on my feet. As mentioned before, I haven't ever had any formal training in coding, but back in the early 2000s, I did build some websites, so I've got some familiarity with HTML, CSS, JavaScript. Also in 2010, I managed to build an iPhone app and launch it on the Apple Store. I did that by taking code from GitHub and basically randomly changing characters for 12 hours a day for 8 weeks. But you know what? It worked, and I was accepted onto the Apple Store, so I must have done something right. So yeah, in terms of AI and machine learning, as I said, I'm like one of the generative AI wave surfers. But when preparing for this presentation, I actually recalled that I do actually have a bit of a background in AI and ML. In 2012, I joined Adobe just as they acquired a company called Fisher Frontier, which was an amazing technology. It was an AI-powered Google Ads buying technology. And it was amazing because it used a thing called portfolio theory behind the scenes, used AI to run simulations, which were forecasts, and people could basically figure out their return on investment for different ad spend levels on Google Ads. And frankly, at that time, it was mind-blowing because you could run these amazing forecasts at the push of a button, and you could see that basically you're going to achieve 90% accuracy on your ad spend, which back then was insane that you could do this. It was a great technology. I worked on the sales and servicing side of it. And as much as I loved it, and I really, really love this technology, I still think it's a fantastic technology. The technical side of it, the AI, the ML, that was all a million miles above my levels of comprehension, and very much resided in the domain of tech genius at Adobe. And yeah, it was an awesome solution. It was way ahead of its time. I think it's still ahead of its time. And I had a great time in my time at Adobe. And as you can see, I had quite an impact on the company. That purple arrow there is where I joined the company. And you can see the share price just absolutely skyrocket. And investors call this the James effect to this day. But in all seriousness, I loved it. And I was super passionate about technology and all things big tech. Until 2018 and the whole Cambridge Analytica thing. And actually, for a period of time, my love of technology started to wane. I can't quite explain why, but I kind of felt like the great days of the web were behind it. And this feeling lasted with me for a few years. Until one day, something hit me like a boulder falling from the sky. I was watching YouTube and I saw this demo of something called Codex. It was by these two guys, Greg Brockman and Ilya Sutskever, from a little company called OpenAI. And they were using natural language to program a game, and it blew my mind. I immediately signed up with OpenAI, got my API key, and I was in the playground, where I spent many months playing with TextDaVinci 3, the precursor to ChatGPT. I had a lot of fun with the playground. I was getting it to write blogs, tell jokes, write songs, and I would literally show this thing to everybody I knew. I was like, this thing is incredible. And I also knew it could write code. I'd seen the demo. I tried a number of times to start, but I literally had no idea what Python was about. And even like the basics of getting set up and your environments and stuff, it was a chore. And so I stuck to text generation in the playground. Then at the end of 2022, the whole ChatGPT thing happened. The first app to 1 million users, or the fastest app to 1 million users, until, of course, Meta Threads. But we don't talk about that, and that was more of a migration. But then everyone got excited by ChatGPT 3, and I was a bit like, okay, this is cool, but it didn't feel like a massive step for me because I was already pretty familiar with its predecessor in the playground. But then plugins came out, and that caught my attention because one of the things I've been wanting to do for a long time was using ChatGPT and AI to analyze data in Excel files. I love Excel, but that wasn't really feasible until plugins came along. And then one plugin in particular. Who remembers plugins, by the way? Right? Yeah. Who thought they were going to be a thing? Yeah, right. Look what happened. Yeah, and then there was this one plugin. Has anyone heard of this plugin, Notable? Notable. Notable was awesome. It was basically like Code Interpreter before Code Interpreter. You could analyze Excel files in it, and it was connecting into a Jupyter notebook. Notable was a Jupyter notebook. Does everyone know what Jupyter notebooks are? Some people, okay. Basically, they're a way that you can write code and run code very, very easily in like an online environment predominantly. And they're all built around Python. And yeah, Notable was one of the very early plugins, and you could do some cool stuff with it. I love the plugin so much that I actually made a couple of YouTube videos about it, hooking it up to APIs and getting GPT-4 to run analysis. And up until Notable, I hadn't ever seen Jupyter Notebook before. So I was using this plugin, and I would get GPT-4 to do something. It would write some code for some actions in Python, then execute it over Notable. But of course, when you're coding GPT-4, things would go wrong. I would have to start error checking the code, and bit by bit, I was starting to learn little bits about Python and using it with APIs. And I like this plugin a lot, and I thought I'd like to build a plugin. They're the future. So I started watching some YouTube videos. This is like this one by this guy, Liam Motley. He's like massive now. And I saw him running some code in this online coding environment thing called Replit. And so like I did that tutorial. And then a few things clicked together in my brain, and I started thinking, after watching that Codex video, I thought, I'm gonna make a game. It's gonna be awesome. It's gonna have amazing graphics. I'm gonna do like they did in the demo, and it's gonna have a spaceship. And so I start asking GPT-4 to talk me through how to make one of these games, and I realized that sounded like really complicated. So I thought a bit more, and I thought, you know what? Like I can probably write a text-based game in Python. And I did. And here's that game. It's a version of Hangman. The code was entirely generated by GPT-4 over a chat session of many, many prompts. Pretty simplistic, right? But it's got all the workings of a game. It's got logic, it's got rules, it had a loop in it. You know, you get to the end and it will loop you back in. And best of all, you see it in the second, is it here? It's got graphics. See the little ASCII Hangman generating as I get the questions wrong? I was like super, super proud of this at the time. And then yeah, like my mind was blown. I had written a game in this language that I didn't know. I was like, I can build anything. This is incredible. So I started obsessively watching more and more YouTube videos. Here's my YouTube video library. Got about 120 videos in there. And pretty soon I started working on my first chatbot. It was a financial analyst AI, supposed to give intelligent recommendations for investors. So I called it Wolfbot, and I created a basic retrieval augmented generation thing, vectorized a bunch of financial papers, and it kind of works. You could ask it questions about reports and it give okay answers. Like, so in this example, I say, what does KKR, they're like a big investment thing. What do they think about digitization? Provide a summary. And it says KKR believes digital disruption, yada, yada, yada. Kind of worked. And I thought, I'm a genius. So I shared it with an early alpha tester, my buddy Robin. And of course, he asks it, when is a good time to sell my house, UK? And of course, JP Morgan, none of them had that information in their reports. So obviously, GPT-4 didn't have an answer for that. And you know, I suddenly realized this is a lot more complicated than it looks at first glance. But, you know, this was a great learning for me. So I took those learnings and I started to hack together some more stuff, did some more retrieval augmented generation. I fine-tuned the model. Then I discovered Python is awesome at web scraping. I was like, ooh, interesting. So I built some cool web scraping stuff. And then I read about the legalities of web scraping and I started to feel very icky about it all. So I turned my back on web scraping forever. But it was around this time I started chatting with one of my buddies, Dean from Awin. He was also using GPT-4 to write code, and he'd created a script which he'd hooked up to some search APIs, and I was like, interesting. Now he was only running this in code, and I thought, well, I'd already started to build like UIs with Streamlit and Gradio. So we teamed up, and yeah, we built this. It's a custom search tool to find websites. It's basically like a new version of Google, kind of running off Google, that actually works and actually helps you find things that you want to search for. So you can put in a search term, you can specify that you want certain keywords in the URL, you can exclude certain websites as well, because all the big websites are at the top of the search results. What else is there? Hold on, I was going to show you. Yeah, so I'm excluding a few sites here. You can select the number of results. Let's do 10. And then I also put in a look back window on it as well. So you can specify like what are the new website articles coming out like over the past few days. And yeah, like it works. You could download the stuff in Excel. I had like a little table in Streamlit. You could click on a link and like engaging with the link would then take you over to the website. And it was a working thing and we're pretty happy with it. So by now I had a few builds under my belt and I started to get some decent learning. So I'd realized that setting up projects in Python is a chore and a pain. Environmental variables, API key management, all that stuff. I also found GPT-4's context windows very painful as well. Like it would keep forgetting things all the time. It would write some code, then forget bits, which was really tedious. And then I started trying to write some stuff in Next.js. And I realized I hated that. And I was like, no, I'm going to stick with Python. I can do everything I want to do with that. I also learned some things that I love. Pip install. Who knows what pip install is? Pip install is like insane. Pip install is like, you know, for anyone that isn't a code, you can basically install superpowers in your code. Like you want your code to like do math or like generate charts. You do pip install this, that, and the other, and it does it. So yeah, I love that. And then Gradio and Streamlit, I've shown you a bit of that. I love those. And vector databases. JP from Weaviate is going to talk a bit about that in a minute. I love vector databases. They're like my favorite thing. So yeah, I was having the time of my life. Life was pretty good until November 2023, OpenAI Dev Day. Now, don't get me wrong, Dev Day was insane. So much amazing stuff. Faster and cheaper GPT-4 Turbo, bigger context windows, the new Assistance API, my GPTs. Like, I was pumped for this. I was like all in on OpenAI. I was like, here, just take my money, take my money. I was super excited about the Assistance API, this idea of like having a virtual team of like different agents all working together, doing orchestrated tasks. I was like, I couldn't wait to get started. So good. But then there's one detail that lots of people overlooked on Dev Day. OpenAI updated their API and all this new amazing stuff was working off the new API standard, which of course ChatGPT-4 with its window cutoffs knew nothing about. So I thought, okay, this is cool. I can copy paste all the documentation of the new API, put it into my GPT and it'll write the code for me perfectly with all the new. That didn't work. That didn't work. And then on top of that, GPT-4 Turbo started to feel like a bit of a downgrade at times, right? Lots of people were complaining about this, and I complained a lot about it too. And even OpenAI acknowledged this as well. And they said they fixed it, but in reality, for a good few months, actually felt like GPT-4 Turbo was pretty bad. And I started to get a bit sad about this because I felt I'd like lost the superpower. So I thought now is the time to learn how to code. So I enrolled in Harvard CS50, Introduction to Artificial Intelligence with Python. And then I looked, courses like 7 weeks long with 10 to 30 hours a week. And I thought, no, I'm going to keep building stuff with GPT-4 instead. So I did. I kept building and I managed to make, by somewhere or another, some actually okay stuff. I built like a little UI for uploading documents as part of like an RAG pipeline. Could assign meta tags, it would do like all the splitting and embedding, and just I like this thing. I'm very proud of this, and I use it a lot still. And then on the other side of it, I also kind of had my little Gradio kind of search and find stuff in the documents, and you know, this worked pretty well as well. Like, very happy with all of this. But like through all of this, like GPT-4 was still a pretty tough character to code with at times. You know, like you would be coding and it would forget things. And then the worst was like when you would hit a message cap and you couldn't code for like 3 hours. So yeah, that was pretty brutal. But through all of this, my interest in AI continued to grow. I started reading like a lot of research papers, learning about actually GPT-4's amazing capabilities in doing things like predicting chemical reactions, making elasticity calculations. It's got a lot of power under the hood. And then through one of these research papers, I got interested in AlphaFold. And I landed on this Google Colab notebook, which is basically a Jupyter notebook. And like the one I've been using in Notable right at the beginning. And I saw this notebook and I thought, this AlphaFold thing, like this is pretty powerful. It like forecasts or predicts protein folding and stuff. And I thought, wow, someone's using Colab to do something with this. It's like interesting. And then I watched a video by this lady, Lily Cheng, and she's awesome. She did a video about OpenAI assistants, which I was really interested in. And she was running this stuff in Colab. I dropped her a line on LinkedIn and she shared her notebooks. And I was like, these things are awesome. Yeah, I love Colab notebooks. They're like the perfect solution for someone like me. I work across 3.5 different computers, all of them separate. I've got API keys in text, but like, you know, no security management. Anyway, some security management, anyway. All that stuff's a headache. And Google Colabs are online, super easy to run and write code, do it anywhere, store all my API keys in them, and they integrate with Google Drive as well, so you can set up like mini databases and stuff. And then all the AI and ML engineers in the room like rolling their eyes are like, really? Jupyter Notebooks, Google Colab, you know, you only just realized this? Well, yes, I did, and you know what? I love them. And now I can set up projects super quick. I managed to get my OpenAI assistant stuff running with them for data analysis. And yeah, I was very happy about that. And actually, I had a really proud moment with it all. Anyone building stuff with AI APIs, you get to a point where you realize that documentation isn't always that great. They miss stuff or things change and they don't update them. And I hit a problem like this when I was using the assistants, namely how to reliably generate download files that assistants create for you. And like people on the forums were posting about this. And I was actually able to solve this with GPT-4 my own. I was like, legit developers are struggling with this. And I was able to do it. And here it is, you know, like runs a file, saves it in my Google Drive. There's a little chart thing. I was running this like some analysis on YouTube videos. And yeah, like it worked. And I was very proud of that. And since then, I've continued to do more projects. I use Colab for pretty much everything now. I can quickly throw together prototypes, like a product reviews analysis tool using embeddings. That does a heat map thing. I'm very happy with that. And then more recently as well, GPT-4 has actually started to feel like it's getting better again. Feels like it's faster and writing more code. So very pleased with that. And yeah, that's it. That's my story, really. And these are my big takeaways, whether it's coding or learning anything else. GPT-4 can be an amazing assistant. You just need to dive in. And there'll be a lot of bumps along the way, but each one is a learning experience. Also, I'd say, you know, whatever you're doing, make it as easy as possible to jump in and pick up, you know, because there's often little gripes of getting started up again and doing stuff that really puts you off. And also, I'd say, like, finally, like, we do all have superpowers now. We just kind of got to benefit from this stuff and use it. My other big takeaway is that this isn't all just about technology. We also have an amazing community in this city. And thanks to AI getting me started in developing, I've met a lot of cool people who have been really supportive. I've connected with friends, new and old. There's my old buddy David, and I think there's someone in this. Yeah, I see you. How's it going? Yeah, it's good. It's a nice photo, isn't it? I met new friends at work as well. These are like some developers and engineers that I never spoke to before, and we have great conversations as well. So yeah, what's next for me? Well, I am determined to finish CS50. I also want to get more into open source, and I also want to do some more multimodal stuff as well. So yeah, I'm super excited for the future. So yeah, that about wraps it up. But there's just one more thing. My first live demo. So I'm hoping the demo gods are going to be with me here. I'm going to escape out of this and let me do this. And then let me duplicate. Cool. Okay, is that record? I don't know. Okay, right. Cool. Okay, that's that. I'm going to escape out of that. And then I'm going to go into here. Okay, is this showing? This isn't showing here. Duplicate. There we go. We're in. We're in. Okay, so the demigods are still with me. Okay, so this is, I'm gonna do my pip installs and get my mouse. Cool. Okay, thanks for bearing with me on this. Cool. So I probably installed all this stuff already. And actually, I think in Collab, I don't actually need to install all this stuff. So this is like some experimentation with multimodality and using some of the OpenAI capabilities there. So we're doing our pip installs. And just wait for that to run, and then I'm going to initialize my keys as well. Cool. Okay, that's done. That's the longest bit, I think. So okay, so I'm initializing my keys. What's great about using Collab over and over again is I've got all these like little snippets of code that I can keep using over and over again. I've got a little drive mount thing, so that connects into my Google Drive. Okay, that's all connected up. That's great. And then also I've got a little bit of code here as well, which creates a folder for me. That's so there. Folder already exists. No changes made. Good to go. Okay, cool. So what I've done in this is I've loaded in a product feed from an Awin retailer, and it's got like some sporting equipment in it. And then what you could do, I'm not going to take you through all of these steps, but what you can do with GPT Vision, which is the one I'm very interested in at the moment, is you can use it with some instructions to write descriptions of your products. Actually, I've taken those out. Oh, here they are. So here, so these descriptions are written by GPT Vision. It says this New Balance 19V, classic running shoe, premium light grey suede, does a good job of describing stuff. And then if I scroll down, I also have, there's a few other steps here, but the really fun bit is I use an embeddings model to create embeddings of these descriptions. And then on the back of that, I can then, the other thing I like about Collab is you kind of can build some widgets and stuff in there. And yeah, I built like a little search thing for it, and I can put in here flyers hat. We'll just do the first result. Hit search. Cool. So yeah, using embeddings in GPT Vision and the descriptions that came up with these products, basically doing embeddings to then run like a quick search on them. And that's cool. That works very nicely. But then like the fun piece that I like is this. So it's an image upload test. So what I can do here is I can kind of do like a find me something similar. So we're going to upload an image. I've got a few examples here. We will go for this one to start with. Okay, so find me something similar. I'm going to load the image. Oh, loaded. Cool. So my prompt is here. Okay, I'm going to say find me something similar. And then I submit my prompt. So prints underneath that, and I say process image. So what GPT-4 is going to do here is it's already run the embeddings on the descriptions, and now it's going to run an embedding on my query, and it's going to come back with a conclusion as to what I've asked it. So here it says, seems like you're looking for something similar to a pair of New Balance 99 sneakers. Can't provide an exact match, but it gives like a description of it. Now what I can do is, because I've kind of got hooked, I've got this hooked up, I save that description as a global variable, and then I've got another piece of code here, which then runs a lookup to find a similar search based on that. What did it come back with? Top result. Found a very similar looking search there as well. I could actually show you some more cool stuff with this. Like you can upload images of people wearing stuff, and it will recognize what those people are wearing and recommend similar products and stuff. But to be honest, I'm absolutely delighted I've got this far with this demo, and I've probably talked for a long time as well. So I'm gonna cap it off there for this bit. But yeah, I'm happy to open up into questions if anybody's got any. Oh, any questions? Oh, okay, cool. Right. Actually, you can give them that. Yep, that's on. Closer and louder. Closer and louder.
So I just wanted to ask you if you told a repo where we can access this notebook, because I'd like to do some cool stuff with it.
Yes, yep. What I would say is hit me up on LinkedIn, and I'm happy to to share notebooks.
Right,
Yeah,
sounds-
absolutely. Cool. Any other questions? Yep. What?
When you're doing data analysis stuff at work, are you just describing the query you want to do? Okay, seconds ago, or are you asking about like abstract questions? And I hope you could write out.
In Vision, are you, for what? For like analysis, like assistance and stuff. Yeah, what was I doing? So I ran some data from YouTube into it. Pulled, saved CSV, uploaded it to an assistant. Those CSVs are connected to that assistant as a file, and then you just chat to it and it analyzes the data. The limits, first up, the limits on assistants, I was really excited about assistants. Assistants are slow. Has anyone used assistants at all? What were they like? There we go. I say slow, you say mediocre. Yeah, they are. They're pretty slow. They're buggy. You can see why they're in beta. They're exciting for the future. But right now, like you can't see them being taking them to production. You can't see that. GPT-4 overall, I love it. I know there's other stuff out there, but I love it. I love writing code with it. We've got good banter now. I say offensive things to it, and it says, "Thank you for your feedback," and you know it's great. It works very well. Yeah, but yeah, those are kind of some of the limits that. Yeah, it's cool. I'm waiting for the next one though. I feel like we're starting to cap out a bit, but yeah. Any other questions? Oh, he's got one.
I have three.
Three. Okay, cool. Remember, loud and close. Yes. Yeah. You know what? I'm not a coder because I can't write it. You know, I can't sit there and write stuff. I can read it, and nowadays I can understand like when stuff is not working well. But yeah, I'm starting to feel a bit more like a coder. Yeah, but I think there's different things, right? Like when you take stuff to production, that's a different ball game. Like what I'm doing, like, is just playing with things, and that's very easy and very fun. But like if you have to deploy stuff like properly, that's a different thing. So like on that perspective, I'd say no, probably not. Still, yeah.
Thanks. Like as you were building that demo, what's your actual workflow of asking you to like sit at one block, copy and paste the code in, fix it, or do something like you talk through?
Yeah, sure. So firstly, I would say that workbook, a lot of that, like you take stuff from GitHubs and repos and other people have books and you kind of patch some things together. But then like what I find is I gradually iterate over maybe something that exists already. So the assistant stuff I built, that Lily Chang lady, she had like a really nice notebook, but there was stuff in there that wasn't in there. And a lot of people do API stuff, but they don't do any authentication as a step with it, or they'll like copy paste the key in. So like I do lots of quality of life stuff that I work through and I clean up code and I get it to kind of like a little app that I like to work with. And then, yeah, you like bits. The closest thing that I have to do is like when I build Excel sheets, I'll start to build stuff and be like, oh, I'll calculate this. I wonder if I can calculate this. And then like I'll do an additional formula. And like I often have like many cells which are kind of connected and end up with like very complex workbooks. So yeah, coding is a bit like that for me. Like I start off, I get to like a point that I like, and then I continue to just push the boundaries of like what I would like to be able to do with it.
Great question. He likes to double down and be very wrong sometimes.
Yeah.
And when you get stuck in that, you correct bad code.
Oh man, I cry sometimes. Like I've had moments where I have literally lost my mind. Like where I've been coding for ages and it's written this long, beautiful script. I'm like, oh, it's the worst. Like I've been writing this really long script and I was like, oh, it's coming. Can't wait. And then you hit the message cap and it's like, you can't do anything more. And you're like, what? Like we're about to run this. And then, you know, that's kind of gone. But yeah, if it goes wrong, you've got to close the window. You've got to start somewhere else. That could be frustrating because you feel like you've got pretty deep into conversations and good stuff. But yeah, close the window, start somewhere else. Also, sometimes like there can be big differences from day to day. I found I actually felt like when Claude 3 launched, the inference times on GPT-4 for me like improved. It seems to be writing code a lot faster and a lot better quality. And I kind of think that behind the scenes they're kind of playing with the levels a bit. We've got one last question, then I'm gonna wrap it up for JP. Yep, you're okay. You don't want to ask it? Oh, that's brilliant. Okay, great minds, great minds. Okay, I'm gonna call it quits there, everyone. Thank you all for your time. Thank you very much. We might need a minute. JP's up next. We're just gonna do some setting up and sing songs and tell jokes.
Yeah.
Cool. To check in.
Yeah, that one.
Okay. Quick message. Can you please check in with this code? We'll put actually, you know what? JP is going to get ready. We'll come back to this one, I think. Yeah, if we can. Cool.
Okay. Only audio. Let's need to share. Video is audio is coming in through some other comments. Yeah, so we'll share that.
Here's a connection. So I can leave my laptop up here. That should Are you doing audio from your computer?
I don't think so. No, do you want me to? Should I?
Maybe if you want.
Like the input, right? So microphone.
It's audio is going to be on. So
Oh, I'm not showing any video or anything. So
Okay, cool. Okay. So I'll leave my laptop up here and you can. Cool. All right, thank you.
I can still share my screen.
Yes, I'll share the screen.
I work in tech, and then every time I need to like run slides, I'm like, what am I doing? Is that here? Yeah. Yeah. So that's empty. Thank you. Are you able to check if the screen share is working okay?
yeah.
Ah, of course. Yeah, no. You may just get going whenever, or
Yes.
are you all okay to go? Do you want a bathroom break? Sorry. Hey guys, are you all good to go? Or do you want a break or anything? You're fine? You're not gonna just get up and leave? I'll so if you do get up and leave, I'll know it's me, not because you need to go. Which camera is that? Do I need to be in front of like at a particular spot, or is that James's camera?
Yes.
Does it matter? Okay, it doesn't matter. Okay, cool.
Can you share the screen?
All right.
I cannot see the screen.
Hey everyone. My name's JP. I work for Weaviate. How many of you have been to an AI camp where I've been as well before? I think some of you have said hello. So, okay, cool. All right, lovely to see you again. So yeah, seen some familiar faces. So yeah, work for a company called Weaviate. We make a AI native database called Weaviate as well. Sorry. Oh, it didn't stop. That's weird because we were sharing it. How did that stop then?
Okay. Thank you.
It's actually working now, right? Cool. All right. We'll get there in a minute. So thanks, James, for that great talk. He mentioned some things, hopefully they'll resonate with you, which is taking things to production, right? So it's a lot of fun making things in prototype, but of course it's a different kettle of fish, taking that to a production grade. So when you hand over your, prototypes or notebooks to people, and then they're like, oh, great, thanks. That's awful, or whatever. It's because the requirements are quite different, right? And doing what I do as an educator, I, of course, means I don't know much. So I had to learn a lot of stuff in a short period of time. And more recently, I find myself learning about all these production-related tools, which is why I'm talking about it. Also, it just reminded me, I've just added this back on the slide. So if you haven't registered for the lucky draw, please do go ahead. I'll just show you what I've got. Who likes Legos? This is the prize. So if you're interested, please register. Yeah, so that's why I chose this topic, because I find myself learning about all these topics, because a lot of what we do and the features that are building into our product is production related. And they're really, really cool, but they're also really meaningful. And the requirements are very different, like I said, to what you might be involved with when you're building prototypes and working with notebooks, right? Because your goals are a little bit different. So if you've worked on going from a proof of concept or a notebook to a production setting, it might be a little bit like this, right? It's very, very different, and it's a bit of a battle. And why is it so different? I'm just going to move that here. And why is it so different, right? Well, it's because I think the requirements change quite drastically, subtly but drastically. So scale is very, very different, right? So you're working with certain number of objects or users, but there's just more of everything. Reliability is a thing. If something goes wrong on your prototype, you just go, yep, reset, see what happens. But of course, you don't want to do that in a production system. You just get mad. Someone else comes and yells at you. Upgrades, of course, that's related to downtime. And costs as well. When you're building a prototype on your laptop, you kind of don't necessarily think about how much the hardware costs are that you're running this on. But of course, if you try and say, hey, I need X number of, cloud instances with Y amount of memory, you can't say, get out and come back. Then that's not a situation you want to be in either. And that really means that if you choose a wrong product or tooling at the prototype stage, you'll be very, very sad because you'll have to go back and do it again, right? So I want to talk about these topics today, right? Scaling, reliability, upgrades, and costs. Let's tackle them one by one, right? Starting with scaling. So some of the considerations that in what I've been thinking about are these. So object count is one, right? So when James was talking about importing number of embeddings, he would have imported a certain number into the database or just the NumPy array or something like that. But if you go into production, you're dealing with tens of millions, hundreds of millions, billions of these objects. And the users. So if I'm building a prototype or a demo or something, I'm quite often the only user. If you're building something as a internal sort of prototype, whatever, you might have a couple of users. But of course, in production, you might scale, and hopefully, if you're very successful, you'll have thousands, tens of thousands of users, and so on. And along with that comes different server loads. They might be distributed all around the globe. They might access your servers at different times, unpredictable times if you go viral online. How do you deal with that, right? And what are the implications? And all of these relate to really one thing, which is managing resources. These things scale. How do your resources scale? And how do you do it in such a way that is sustainable and that makes sense for everyone, right? And at the end of the day, you're trying to build a product and make money, most of us. So here are some of the things that will help you, or some of the things to think about that will help you do that. So if you're dealing with growth in numbers, this is what your workflow looks like in a database, right? You got a bunch of things. It might be documents, videos, images, whatever. You turn them into vectors, ingest them into a database. And then you're like, okay, as that grows, what do you do, right? Of course, you can get larger servers and larger servers. And then you start to run into limits, as well as some difficulties inherent in scaling vertically that way. One is that it's a single point of failure, right? You've got this massive, enormous server. What happens if something goes wrong? If you're, someone AWS pulls out the cable or they have a failure. Costs don't scale linearly, right? And it's not very efficient either, because it means you're always running that big giant machine. That's not an ideal solution. And then how do you again upgrade that instance, right? Because you got to take it down to upgrade. You can't, computers are computers, right? So a good solution for something like that is horizontal scaling, or what's called sharding. So if you hear about a feature like sharding when people talk about databases, that's really all it is. It's like sounds very technical, but really all it means is that you're able to split up your database and distribute it into multiple parts of it, and they can be spread out. And just by the out of interest, and just so you don't fall asleep, how many? Can I just get a show of hands on how many people here are either data scientists or developers? I'd love to see how many people are tech people. Okay, cool. So it's about, I think, about 2/3. So I do apologize in advance or in the middle of my speech if I'm like going too deep into tech or not enough. It's a fine balance, but feel free to come and ask me any questions after. So with sharding, what happens is you deal with growth by cutting up parts of your database into different components or different nodes in your cluster. So in this example, you might have your green components of your green part of your database in your green node, blue, and orange. And that means to scale, just add more nodes, right? Because they're all split up, and all you need to do is add more nodes, and they get distributed in this like really cool deterministic way. So they're not messy. They're kind of like, they go where they're supposed to go. And for us, with our product, with Weaviate, I saw this demo about a year and a half ago now, where they like, oh, we added like 1 billion objects, billion vectors into our database. And my first question was, why? And the answer was to see if we could. And B, where did the data come from? And they said, don't worry about it. They told me about the database, which is called Sphere, the data set, which is really, data science for data scientists. But it's really cool. And the fact that they've been doing something like that for that long means they've been able to think about these issues and how to do it, and what kind of issues in reality when you scale to those types of numbers, right? And it's really, really cool. So if you have more nodes, of course, going from 3 shards, you just go into smaller shards, right? And it just goes on and on. And from an end user perspective, and this is from your perspective, what's probably really nice is that to set up something like this, it's like a couple of lines of code, So if you go from a prototype and then you go, oh, I want to have more shards, you just change the number of shards in this instance. You actually need the computers or the cluster nodes to actually for the data to go into, of course, as well, right? But in terms of setting up sharding at the software level, this is all you would need to do. And that's nice. It's nice to be able to go, oh, right, I need to scale. Oh, no, I need a whole different software library. And that's not a nice feeling, because I've had that with things like, certain data science libraries, like let's say Pandas. Pandas doesn't necessarily scale all that well. You have to go to things like Dask, which is like disk-based, because you just run out of memory and can't do anything. So just having a library that scales like that is really nice. Another part of scaling is indexing. Can I just get a show of hands again so I don't bore you too much? How many of you are familiar with vector database indexing, like terms like HNSW? Okay, cool. Thank you very much. So the trick is, if you have a bunch of vectors, you're probably familiar with the concept of indexes, or certainly how many of you, I'm sure many of you have been to libraries. I'm kind of starting to date myself a little bit when I say things like the words like libraries with physical books and things. But indexes are basically things that help you find information faster, right? You go to a library, you don't look through every book in the library, right? You look through some sort of computer catalog, or like used to have index cards back in the day, those things. And that's what an index is in a vector database. It helps you find the right object faster. So this HNSW is just a way of building that directory of things so you can find things faster. But then there's other options too, something called a flat index, which is used for different purposes. And they are really 4 different use cases. So when you want HNSW is when you have lots and lots of things and you want to build them in a scalable way. So when I talked about billion objects, that's really like, let's say, 1 billion records of, if you're vectorizing an entire library, like entire human knowledge library in text, right? You might use something like HNSW. But if you're building something like a bunch of medical records, right, where all the records have to be separate and isolated, but there are also only few of them per set, you might use something like a flat index. And the point is that they are technically very different and they serve different purposes. But because they are different and they serve different purposes, you want a tool that can do both, right? You want a tool with that kind of flexibility so that if your use case changes, or if you go from a small set of data to a very large set of data, that you can do that. And again, for me, I actually learned about all this detail fairly recently. So I can, again, talk about it and try and, look a little bit smarter than I am. But in terms of implementing it in code, it's again just a line of code and very little changes. So all of that complexity that I talked about is abstracted away from your perspective as a user. And to me, when I'm building like even things like demos, oh, this is really easy. I don't have to spend a lot of time just like fiddling around with this. And it's the same when you build production code, because all of the implementation details are solved for you. Let's talk about efficiency a little bit more, right? And if you have lots and lots of vectors, they take up a lot of space. And if you have a billion vectors, that's a lot of memory. So how do we reduce that? Can we do something? One way to do it is actually just compression, right? We've all, hopefully you've seen compression with things like zip files, right? On the internet, JPEGs, when we download movies from Netflix, data's compressed. And you can do the same thing with vectors. There's a couple of different ways to do it. One's called product quantization. And you won't be surprised to know that I only learned the detail of this very, very recently. And it's really, really cool. So what's happening, and don't worry too much about the exact detail, what's happening is that you have a list of numbers, which is what a vector is. And with product quantization, what you're getting is fewer of those numbers. So instead of 1,000, you might have 100 or 200 or something like that. And then each of those groups of numbers, what we call segments, are quantized. So you're basically choosing from a pre-selected group of, say, 256 numbers, right? So if you're a data scientist and you've seen things like quantized models, this is basically the same concept, except now you're applying it to the idea of how your vectors are stored. And that gives you really, really cool properties like customizable compression, right? Because you can choose how to compress the length of your vectors into segments and also the level of quantization for those vectors. So as an example, you can go from 128 dimensional vector to 32 quantized numbers. So it's 4 times less. And also each floating point number, I'm getting extremely wonky, I know, sorry, into a byte. So that's 4 times, so it's 16 times less data. And that's very cool. And another thing which we've implemented is called binary quantization. And this blew my mind when I saw that this works, is that you go from having a bunch of floating point numbers to just basically a bunch of ones and zeros. Like that's all you do. And it works. Like I said, how could this possibly work? So you're going from a bunch of floating point numbers to a bunch of bits. So you're getting 32 times reduction because each floating point number is 4 bytes. And this works well because you still have, if it's an OpenAI embedding, 1536 numbers. It's 1536-bit embedding. That's a lot of information you can store in that number. So this works really, really well for, quite a few embeddings. And there's other tricks you can, apply with this as well. What you can do is mitigate some of these losses by getting a few more candidates right in your search, and then rescoring them with the actual vectors. So this works really well. And from, again, a user perspective, because all of that was me technically saying, hey, this is a lot of cool stuff, but it's all implemented. But really, again, from a user perspective, you really want a tool that can, give you these options, because you don't have to compress them, right? But it's nice to have these options to reduce your memory requirements. And try, something like PQ with default options. PQ works well for certain models, but, it really depends. If you're not sure, just try PQ. Basically get like reduction in memories for free or memory requirements. And how to use each, you're going to be, once again, blown away. Just another line of code added to your code base when you import your data. So that's why even someone like me, who's talking about Weaviate day in, day out, writing example code and stuff, I hadn't necessarily looked into the nitty-gritty of like how this works, because you don't have to, right? I can build all this stuff and just happily start to use it. And if you're using product quantization, just do that. It's basically the same code. I think there's like 5 letters, characters difference between the 2 code examples that I showed you. It's just absolute magic. Do you have any questions so far? Haven't lost the crowd. Yeah. Yeah, you would have to define that at the start when you define the collection of objects. You can't suddenly switch from one to the other. You'd be like, yeah, you can't do that. Yeah. I guess that's the same as any other model. So the question was, how do you, can you switch between the compression schemes? You can't. And then the next question, which is a really good one, is also how do you know it's basically working, and then how do you make those choices? It's kind of same as like choosing any other embedding models when you're creating these. You can't ever switch them because they're basically different languages. They don't they're not compatible with each other. So every time you do that, you'll have to restart. If you want to change your embedding model, you have to restart again anyway. So you have to rely on things like other people's literature, the model designers like literature on like what works for what purpose, that sort of thing. There's specialized models for different domains and stuff like that. So it's really horses for courses type situation there. Cool. Yeah. Yeah, it depends on the model, but in that example I showed, yeah. So you have to make sure that the model is equipped to do that, because if the model is like more skewed to have more numbers one way or the other, you're not going to retain enough information by turning it into a binary classification, right? So really, that's why it's a lot more sensitive to how the model is trained and what your final distribution looks like versus things like product quantization, which is like a little bit more, quite a bit more robust because there's a training step. So yeah, cool. All right, well, I see you're still here. Most of you are probably not asleep. So let's kick on. Some of the other things that are really cool is dealing with end user growth. So, going from me and my colleague playing with the POC, what happens if you have a bunch of users, right? Well, some of the challenges that come with that are things like, hey, how does your performance change? How can you isolate your data? Can you achieve compliance? And the solution there for us was to actually develop a whole new feature called multi-tenancy. And this is really cool because what that allows you to do is have per node easily thousands of users, right? Be able to serve thousands of isolated users and their data. And you can have hot cold tenants. And I keep coming back to the thing about reducing your memory requirements when you host these databases and things. And with isolation, I don't know if many of you have dealt with like compliance issues and things like that, but if you have user data and you need to say comply with GDPR regulations and go, oh, I need to delete user 1435's data and prove to me that you've done that, it might seem like an easy task, but it's not necessarily. But if you have multi-tenancy set up, you can just go, oh yeah, I'll just delete that entire collection. All the users' data's gone, and I can easily prove that, right? And things like hot cold tenant is also a really cool feature. And what that allows you to do is to, if you've got some users that say who are, it's nighttime for them, right? Or less active time, maybe they haven't logged on for a week, just push their data to disk, and then they're not taking up memory. So again, it reduces your instance requirements and it makes your, we can reduce your costs. So it's really, really cool feature. So those are some of the features that really allow you to reduce your needs or deal with the issues that might come up in scaling. Enough of that. Let's talk a little bit about reliability. I just really like this meme, so I just had to have it in there. No one likes it when your server goes down, right? It's not fun. And the thing is, when you're in production, these issues of like, hey, how do you make sure your data is consistent? How do you reduce downtime and disruption? How do you make sure that you have backups in case things go wrong? And, how do you achieve those? Because 99% of the time, things work fine and your users are happy, right? But the moment things go down, like whenever it's kind of amusing for me to watch the chaos when the OpenAI API goes down every so often on Twitter, and people just, just chaos. So you don't really want that. But the thing is, we've all dealt with computers, right? Computers fail. Like downtime is a thing. You're never going to not have downtime. So what do you do? And the answer is a system that can replicate your data and provide redundancy. So if you haven't looked at replication before in a database or other types of setting, the idea again is very, very simple. So instead of having your object or data go into one node, send it to that node, this node, and this other node, so that there's a copy in multiple nodes. And what does that mean? Why do I care? If you're a user talking to that cluster, and then your cat's pulled out one of the plugs in on AWS, well, that's okay because you can't get to node 1, but hey, your data is also in node 2, it's in node 3. Your cluster says, cool, I found 2 copies. They're the same. Here's the data served for you. Don't know what's happening with node 1. We'll figure that out later. And the user doesn't notice. They sent a request. They got their data. Happy days. So what that's doing is turning something that's basically inevitable in terms of node level downtime. But at the system level, you've got robustness, right? So that's all fine. Hey, surprise, I've got another code example with one more line of code that you have to add to get this. Again, you do have to have the physical computers somewhere to provide replication, but this is at the code database level, all you would need to do to add replication to your cluster. You can combine these two things. So if you have sharding with replication, let's say you have 3 replicas of the orange shard and 3 replicas of the blue shard. I was going to say orange, green. That's not right. So you can combine these things, right? So you can have 6 nodes, 3 replicas of each, and you get benefits of both. And backups is something that people don't think about. You would not believe the number of times our users go, oh no, I've forgot to back up my data, or I need to move my data from X to Y. How do I do that? And you'd be surprised that not everyone lets you do this to achieve, I guess, vendor lock-in to some extent. So can your database perform local or cloud backups? Can you export your data, right? How hard is it? And look, for us, we're an open source company. We are, yes, we obviously are a commercial entity as well, but we are an open source company. It's really important to us that if you want to get your data out of our system and go somewhere else, or if you want to go from our SaaS offering to our open source offering, that's fine. We're perfectly happy with that, and we provide means to do that. So this is, again, a code snippet for backup. It's so easy, I could do it. Same as data migration, just a few lines of code. So in terms of achieving reliability out of the box, these features like having replication, having backups, can you export your data? It gives you that sense of reliability. And of course, the actual, reliability when you do go to production without having to switch systems, without having to, come up with your own backup like solutions on top of whatever you've built. So yeah, it's very important. Upgrades is a related topic to reliability. If you've upgraded your system in production before, it's probably not fun. And all the things I've talked about before, like having sharding with replication, helps you do that because the robustness that you get when your nodes go down, right? We talked about the examples here, is the same when you have a node in maintenance, right? It's exactly the same thing. It's out of action. It's having the core software upgraded. So you go, okay, these 2 other replicas will do the job. And the same thing if now node 2 is being upgraded. And that provides redundancy. Again, for the end user perspective, it just works. They get served the latest version of everything. And unlike Harrison Ford, you will survive without getting crushed by a giant ball. Did he survive that movie? So that's upgrades. Let's talk about costs. I think I've got about 5 more minutes, so I'll try and get through this. And some of the considerations when you talk about costs, it's really a combination of all the things we've talked about before, right? But there's also a few other things, which is at a more higher strategic level when you make business decisions. Also, when you make technical decisions, they also become business decisions too, right? When you want to go, if you're using Weaviate, it's great, but do you use a self-managed open source solution? Or do you use our SaaS product, right? What trade-offs do you make? If you're using some compute resources, do you go with something like AWS or Google or whatever? Or do you use your own resources? And then what trade-offs can you make between cost and accuracy? You know, can you sacrifice, can you use compression? Is that okay with you? How much compression is acceptable for your use case? So these are only, oh yeah, and how much redundancy, right? Of course, I talked about, hey, you can have redundancy, that's great. But of course, that's extra compute, that's extra storage, that's extra nodes. It all costs money. You'll be happy to know that I cannot provide an answer that works for you because I don't know your situation. But these are some of the key considerations to think about. So if you're looking at things like SaaS versus self-managed, you know, there's pros and cons, of course. I'm sure you're quite well aware of them. But really, depending when you're choosing tooling, think about, hey, how easy would it be if I change my decision later, or if my situation changes, can I go from one to the other, right? And if you're talking about cloud versus on-prem deployment, sure, no one easy answer. But again, can you go from one to the other? And it's really frustrating building something and then going, oh, I am locked into this particular version of that solution. And that's not a great place to be in. And the same thing with costs and accuracy. So obviously there's like accuracy in terms of index configurations, compression that I talked about. I would say if you are using Weaviate, and not even if you weren't using Weaviate, I would say go with whatever default options they give you and some sort of compression, because they probably wouldn't have it in their product if it wasn't, you know, a good starting point. So I would say that. And redundancy, if you really need uptime, I would say start with a replication factor of 3. So I feel like I talked a lot. And that's because really there were no shortage of things for me to talk about. I think my CTO is doing a series of talks on like going to production. He's a great listen, Etienne. So if you want to, you know, look up some talks on the internet, check him out. But these are just some of the things you might want to think about when you go to production. And it's difficult. There's a whole field for a reason. So choose a tool that really won't set you back to square one. Because I think to me, that's decision that you make when you start prototyping. You should have in mind, will this tool get me to production when I have a successful prototype, when I have a successful notebook, when I have a successful, you know, demo. So that's it from me. Thank you very much. Hope I didn't go over time or too much. And yeah. And yeah, I'm happy to do questions now or later. Yeah, let's do questions if you have any questions. I can yell. I think I've been yelling. I'm very sad I can't register for this Lego draw. So that's a really good question. So did you say how many nodes do you need to get quorum? Yeah. Okay. So there's a couple of things. So when you're doing operations, we have tunable consistency. So you can do it with operation. So with the consistency level of 1 quorum or all. But for quorum, it'll be n over 2 plus 1. And we're switching over. We're working on a new replication system as well, where we're introducing Raft as a coordinator, but that'll be only for schema configuration at a high level, and then the write would be still leaderless. If you want replication, you should have 3. You can do it with 2, but it's worse because, yeah, you can't ever reach quorum if you have 2. Yeah.
Yeah, scale. Like when I was playing with something embedding something like the image, and I started like doing that, and, you know, basically got big product things, really like running embeddings and all that, that's got to be like pretty expensive, right? If you're doing that like scale and managing that.
Yeah, so there's like a few different parts to it, right? Embeddings, like creating embeddings these days are quite cheap, which is nice. Like even multimodal ones, like I run these demos all the time, and my OpenAI like bill is never more than like a few dollars, and most of that's like not embeddings. And I'm quite often like vectorizing tens of thousands of objects. If you're re-vectorizing tens of millions of objects, that's going to be more, but it's not. It's fractions of what it costs to run large language models, like for inference. And then where the costs really start to come in is if you're vectorizing tens or hundreds of millions of vectors, and then you kind of need to deal with the memory requirements of serving it, continuously.
And in terms of like the scale of use cases, like when people come to Weaviate, what are like the top 3 or so use cases people come to talk to you guys about?
That's a really good question. A really cool one is like, so we're a database and search company, right? So a really cool one is like e-commerce. So when you were showing the e-commerce example, I was like, oh, this is awesome. So, e-commerce companies or e-commerce use cases, you have a lot of, data, multimodal data too, right? Like images and descriptions and whatever else. And then you can just ingest all of that and you can do multimodal search and multimodal generation these days too, which is really amazing. Another one is when you have like, any case where you have a lot of text data, right? So legal domains is another one where, in businesses, when you have a lot of unstructured text data, is another big one as well. But yeah, basically, it's like any other NoSQL database, right? It'll take anything to some extent.
Yeah, because I started thinking about products, I'm like, you need like a really great system to manage this stuff and do it really well.
Yeah, I think that's right. And it's interesting with the NoSQL database like Weaviate, because you're a database, but you're also a web server, right? Like you kind of forget that a little bit. So the throughput and the efficiency of the web serving part is also very important. You can have a database that works really well in demo, and then it can produce it, and you're like, oh, how many queries can you serve? It's like 10 queries a second. It's like, well, that's not very good. It means like if there's like a couple other people logged on, you're not going to get your queries served. So yeah, the scalability and where the rubber hits the road at that side of things is really important. So yeah, it's a really good question. Cool. Thanks very much.
That's my board game group. Just ignore it. I never thought of that. We need any audio on this, do I? Like, don't need audio, but we're using. Are we using this one?
Yeah, we don't need
We don't need the audio. It's something. And showing screens. Where is it? Lost it. Okay, thank you. I want it in green, the big massive. Yeah. Whole screens. There we go. It's fine. Okay. All good. There we go. Perfect. Yep. All right. Yeah, thank you. Okay, thank you. Start timer. Okay, thanks, folks. Thanks for sticking around to the end. I'll try and not go on too long. I can get rid of this little feed here. Okay, so this is me. I'm a contractor consultant type guy, and I find myself doing a whole bunch of different projects with a whole bunch of different people as a result. And right now I'm working with a really great digital agency called Caution Your Blast. And for the last year and a bit, I've been working with these people to build services in central government. And I'm going to share a little bit about a project that we're working on just now. But before I do that, it's just to share with you that I was at a thing today, all day during the day, on AI in government, and there's so much going on. There's so many people doing really, really interesting things. And I was surprised at the scale of it and the amount of expertise and knowledge. There's some real cool innovation there. So this is just one project that we happen to be working on, but there's a whole bunch of interesting things happening. I'm going to start by trying to go back in time with you a little bit, just to this time last year. If you can remember last year, a long time ago, actually tomorrow, a year ago, March 13th, is when GPT-4 was released. And there was already a lot of hype based on ChatGPT, and people were very excited about it. But this crowd might be a crowd that remembers like the level of shift when GPT-4 came out, but it was incredible. And it was blowing my socks off. And you started to see headlines like, GPT-4 is ushering in a new era of AI in medicine. Wow. We might not need doctors. And even better news, GPT-4 can pass the bar. We might not need lawyers, But it really looked like that, right? The one that got me genuinely on the edge of my seat, could not believe what I was seeing. I watched 3 different presentations from the authors of this paper. They were literally dropping the phrase sparks of AGI. AGI, right? Sparks of AGI. They're not committing, right? But they're saying this thing is kind of a little bit like that. And I just could not wait to get my hands on it. And neither could anybody else. And this is what I think launched such a massive surge of interest. And that's why there's so much happening in government, because the government also gets caught up in all this stuff as well. And they want to take advantage of these things to empower people and to make the efficiencies the same as everybody else. If I had a record player, I would now do the record scratch, because it's a full year later and nothing is as simple as it seems. In the last year, do you remember this case? The lawyer that used ChatGPT and got himself in a lot of trouble because ChatGPT hallucinated. We all learned what hallucinations are, Oh, it turns out your computer can have a dream, have a bad day as well. There was the case of a Chevy dealership plugged in OpenAI into the chatbot, and all of a sudden it's recommending competitors' products. Just a couple of weeks ago, the now famous case, this is the case that gets mentioned most in the circles I'm in just now. Air Canada losing a case where their chatbot hallucinated, I think it was a price it hallucinated, and they were held to be responsible for that price. So that's a bad thing. And I checked to make sure I was still correct. And as of 2 days ago, this is a screenshot from Reddit. There are active Reddit communities dedicated to jailbreaking every LLM, including GPT-4. And this is a live jailbreak as of 2 days ago, right? So if you're building a system on one of these things, oh my God, so much can go wrong. And that's the background. Before I tell you that in 2 weeks, we're going to go live with the OpenAI GPT-powered question answering service on a gov.uk domain for the Foreign Office. And that's just to kind of set some stakes. I watched a storytelling podcast that said set stakes at the start of your talk. So I'm doing that. So the takeaways of this talk today, right? Here's what I'm going to actually tell you. I'm going to tell you how we mitigated most of the risks away from using LLMs. It's not free. It doesn't happen without losing something cool, but I'm pretty confident we've got rid of most of the risks of using LLMs. And it's very thematic, given we had a talk from a vector database, but we had some difficulties with getting our vector embedding search working. And I'm going to show you a little bit about the problems and what we learned from them and how we kind of solved them. So it's more of a kind of, here's a bunch of stuff that we found as we tried to build out our system kind of talk. I thought it'd be important to tell you the context of use, right? So the Foreign, Commonwealth and Development Office, that's the ultimate client. And they have a problem of over 500,000 inquiries every year coming in. So what kind of things do they do, right? This is the part of the Foreign Office that helps British citizens. So if you are in Spain and you had your passport nicked and you're flying home in 10 days, you know, the Foreign Office can help you get an emergency travel document. Everything you need is starting to become better and better and better served through these online services. And most online government services are getting pretty good now. Not all, but most of them. And if you were to, you know, go look for it, you'd find your answer. But a lot of the time, for whatever reason, digital literacy or, you know, confidence or time or what have you, people want to ask and they want somebody to tell them where to go, what to do. So this is what the 500,000 are. Now, the team that handle these inquiries, they're all extremely trained experts on all the services offered and how they work, right? But they can only do what they can do, right? And typically on a good day, you're getting your thing answered in 2 to 4 hours. And if it's busy, if people are sick, or if there's a crisis, and when is there not a crisis just now, it can take up to 10 days, right? If you're traveling home in 10 days, you've lost your passport, you need that answer a lot quicker. So the motivation behind this is twofold. It's to improve the service to users by getting them answers quicker. And it's, of course, to, you know, get a saving in terms of staff time. Now, ideally, that staff time will then get used on the really hard, complex cases, the cases that need that concierge service where a citizen is in a kind of bad situation, they need a real helping hand. I don't trust the demo fairy, so I'm going to show you Blue Peter style. This is what it looks like. It will be live in a couple of weeks as part of a planned rollout. We're doing we're putting these on the embassy pages. So wherever you would normally go to contact us, you'll first go through an old-fashioned triage system. It's just a tree essentially. And most of this is not AI. Most of this is just good old-fashioned high-quality service design. At the end of which if you're not found your answer here, you get a nice little text box and the AI has a bash at answering it. And this is the AI having a bash at answering that question about getting married overseas. And if you don't like that answer, you can still escalate it to a telephone number or a contact to a human being. So we're not eliminating that. We're just trying to help you get your stuff quicker and free up, hopefully, all the time that would be spent solving the easy cases. Now, if you plan on doing this kind of thing, I'm sure half of you are already filling in the gaps on the design. In fact, I'm pretty sure this gentleman already made an appearance in the screenshot from James when he was showing us his videos. It turns out it's really easy to connect ChatGPT to your data. In fact, it only takes 10 minutes. And that is true, providing all you're doing is a little prototype. And it's a theme of today by accident, I think, right? That the difference between prototype and production is a gulf. And that's where the hard work lies. So it's easy to do the RAG thing, as you've maybe heard the phrase, but it's hard to make it work as a full product. Now, can I just see who doesn't know what retrieval augmented generation is? Does anybody here not know the term? Only a couple of people. So luckily, I get to not go into depth on that. Every AI event I go to, somebody tries to explain what RAG is. And I need to give a little bit of context, but I'm going to not spend too much time. It's a technical term for something that's quite a straightforward idea. Retrieval augmented generation is the phrase. Retrieval is just grab a bunch of stuff that you think might help you answer the question. And then augmented generation is like show it to the bot and then say, would you please answer the question using the information we gave you? It turns the conversation with the chatbot into a reading comprehension test for a chatbot. It's like, read this page of Wikipedia, then answer these 5 questions about it. It's that kind of a mental model, right? And that's what those tutorials you'll see if you look into doing this yourself. That's what they're all going to show you. And it's a really cool technique, right? There's a reason people love it, right? It's really cool. This is a RAG bot that we built, a little quick early prototype. And the data we're connecting it to is from the UK Foreign Office's travel advice service, right? So it's 226 countries. We've got advice about security, safety, visa requirements, all kinds of stuff, right? So this is a real question from a real citizen that they asked the contact center. We land on the 1st of January and we have a return flight from Philippines, 1st of February. Since we're only overstaying our 30-day visa by 12 hours, do we need to pay? Okay, so what they're saying there is they're staying for 30 days and 12 hours, and behind the scenes, like you might not know this, I didn't know this, but you have a free 30-day visa as a tourist if you're visiting the Philippines. So you can see that they're now on this border case. They're curious as to should they worry or not. And they're throwing out a second question, right? We're flying to Vietnam for 3 days in the middle. Is this a big deal? Is this going to reset our clock, right? We're going to get a second 30 days, right? So they're asking these questions. Now it's connected to the data from the Foreign Office. It's got access to that. And let's look at what it says. Start at the bottom, right? So one of the things you really want when you build a RAG thing is you want it to not answer stuff if the answer isn't in your data. So if you look here, it did a great wee job, right? I'm happy with the bot here. Regarding the Vietnam thing, the bit in the middle, information provided does not specify. Excellent, super happy, high five, gold star. But let's look at the way it dealt with the first part of the question. Based on information provided, okay, we're so far so good. If you're only overstaying your 30-day visa by 12 hours, okay, it is unlikely that you'll need to pay a fine. Unlikely? That doesn't come from the data, right? That is not true. That is the hallucination thing. Let's run it again, see what it says, right? This one looks so much better. There's no speculation in this answer. I'm not going to make you read the whole thing. But right in the middle, for no good reason, it claims that the fine is 1 million Indonesian rupiah per day. That's not even the currency. Okay, so hallucinations, right? We know it's a thing. I love this stuff, right? I love interacting with large language models. I don't want to go back. But when I do so with a defensive stance where I know I can't fully trust it. I can't drop my guard, right? If you're serving 500,000 of these in a year, and if 1% are bad advice that people act on, that's 5,000 people that could get in trouble. Our worst case scenario isn't one of those funny stories in the newspaper. Our worst case scenario is a British citizen in harm's way, or somebody jailbreaking these things, making it saying something horribly offensive and causing a diplomatic incident. So we had to find a way to do this because the government is the most conservative, and I don't mean politically conservative party. I mean conservative. You can't afford to make these kind of mistakes, right? You can't put something on gov.uk that's going to get somebody taking a risk. Oh, you're probably not going to get a fine, right? You just can't do that. So the takeaway is to shut ChatGPT up, right? We use the brain of the LLM, but not the mouth. We use ChatGPT without the chat. We're taking advantage of the natural language understanding of the model to understand the user's question, but we try to really restrict it and not let it come up with random answers. I'm just going to show you how we did it through a wee swim lane diagram. So the user is up here. The user submits the query. Okay, so user submits a query. It goes into a web app. Web app is inside the FCDO's infrastructure, and we have a little Python app that you can access through an API that you can only access if you're already inside the infrastructure. So our AI parts are not visible to the random web, only visible inside the secure IP locked within the infrastructure. But the user's inquiry comes in. It comes into the Python web app, and we do the little RAG thing. So we have all these articles in a database. This is the trick, right? In this database are all of the answers to people's questions. The way the contact center currently answers these questions isn't by handwriting a custom response. They have a library of what they call knowledge articles. And the knowledge articles cater for all the kind of things people engage them about. So if we're going to try to send back the exact article rather than let ChatGPT talk to you. So we do the embedding similarity search that is what powers these RAG bots. And we bring the articles back, the candidate articles. These are the potential ones that are the closest based on the similarity search to the user's inquiry. And then we ask the large language model to pick which one of these is the best answer to the user's question. And if you were doing a RAG bot, this is where you would then generate the text and pass it back out to the user. Instead, we just generate the ID number of the particular article. So we send back an integer, a knowledge article ID. And the web server, this is the ordinary old school web server here. This is not the AI like bit. It has a job to separately go into the database all by itself, bring back the article that has that ID number, and that's how we render it to the user. So you see, we've sacrificed all the flexibility of back and forth chat and your ability to refine your question, all those amazing things, because the operating model in this real world environment is far too risk averse to allow that freeform thing. This is what the data packet looks like, and you just see there that 8 is the thing that is the ID number. Now, like this actually does work really well at preventing downstream hallucination impacts, downstream jailbreak impacts. You can assume the packet of data is poisonous. You can assume all the way up to like this last stage here that everything that's sent in JSON between the Python and the web app is actually bad data. Could be saying anything in there, providing the web app only fishes for KAID, the knowledge article ID, and providing it only treats it as an integer. There are 2 things that can go wrong. One is we can serve the wrong article to you. So you ask a question about getting married in Thailand, we answer about how to renew your passport. That's the wrong article, but it's not bad advice. It's not going to get you in trouble. And it's basically the same thing if it's a jailbreak, right? If you assume the most offensive stuff you've ever seen in here, and it turns it into a number, what would that integer look like? I don't know. But it's not either going to find a random article or it's not going to find anything in the database. It's just going to return, sorry, we couldn't help you. So this works really well as a way to, at some cost of user experience, keep it safe. It really relies on having a good data set of pre-written articles, and these we have that data set, and they're all written by content designers. They're all pre-approved, and that's what it hinges on. Now, when we started to actually test this, we felt good about this part of the design. But when we we grabbed a bunch of cases from the contact center, real cases that they had answered in the real world, and we wanted to compare our answers to the answers that the contact center gave. Which articles do they choose? Which articles does the tool choose? It chose the wrong answer almost every single time. And that is the thread that we pulled that leads us to the second takeaway of the talk, the one that's related to the embedding and the difficulties we had with similarity search. This is my very brief reminder on how the embedding search stuff works. If you don't know RAG, this is what powers RAG. So you're going to have your data set, whatever the data your organization has. And in this case, this is the travel advice data here. And you run it through one of these embedding models that you heard JP mention, and it returns it into like a little number. Now, this number is like 1,000 plus or whatever. But you can think of it like a coordinate. So you've got an X coordinate, a Y coordinate, a Z coordinate, an A, a B, a C, a D, a E, and it just goes on for like 1,000 plus, right? But it works like a coordinate. And the whole idea hinges on the fact that, see if 2 things are kind of similar in the meaning, they're going to end up kind of similar in the coordinate. So if you look at this little diagram that I half stolen and edited, entry requirements for going to the Philippines is going to end up kind of similar in that coordinate space to visa requirements, because they're both kind of about things you need to visit the Philippines. Whereas healthcare facilities, it's not like miles apart because it's about the Philippines, but it's further apart than those 2. And the trick that's got 1 million YouTubers, hundreds of thousands of hits, is that if you ask a question, do I need a visa for the Philippines? You turn that into a coordinate and you go fishing. You go fishing for anything that's nearby, wherever the question is, and you bring back all the wee guys that are potentials, and that's what you show to the RAGBot. And in our case, that's what we were shown to the AI in order to have it pick the best article. And this is where it was going wrong for us. We were returning the wrong articles every single time. And it's because this is what our articles look like. This is what our actual data looks like that we want to serve to customers. I'm not going to make you read the full thing, right? But the one on the left says, sorry, the FCDO can't help you. You should probably go look on the HMRC website. And the one on the right says something along the lines of, sorry, the FCD can't help you. You should go look somewhere else and good luck. You need to figure out what that is. I.e., the meaning of the data here doesn't necessarily directly relate to the question for which you would choose this answer. If I'm saying to the AI thing, hey, look, I'm living in Germany. I was in the UK for many years, and I think I might like to retire in the UK. Is my national insurance up to date? How do I figure that out? Like the meaning of that stuff I just said to you, the meaning is what gets turned into that coordinate and gets shoved into that database somewhere. That meaning is going to be miles away. It's going to be over here somewhere compared to the actual answer, which is you should go talk to HMRC, not the Foreign Office, right? The fact you're in Germany doesn't change that. It's an HMRC thing. So the articles don't have a high semantic match with the questions. So all of this RAG stuff, it only works if the thing you're doing your input on matches in an underlying meaning semantic kind of way to the data that's in there. We have a disconnect between the answers we give. This one answer would be given to loads of different questions, right? This answer is given to loads of different questions, and they're very different. So that semantic disconnect was the issue for us there. So we got rid of the RAG thing, and we started to build out a sort of new representation of the same data set. So this is the ID numbers. This is the English language shorthand to remind you what article you're talking about. And we started to test writing essentially these selection criteria, we're calling them. They're a mixture of a kind of topic description, like these are the topics that this is about, plus a little bit of like expert system style rules. So it's a mixture between topics and rules. So for example, the first two are about notarial services, getting a document stamped, right? Proving that it's a legal, legit document. We've got a version of that. These are almost the same, right? But the one down here is for getting married abroad. So they're kind of similar. They talk about similar sort of thing, but you'll see here I'm saying, unless the purpose is for married reasons, and down here it's like especially for married reasons. So you're kind of mixing and matching the topic modeling, kind of like these are all the things that this is for versus the rules. Now this is a nightmare because it's a ginormous prompt, right? Every article has a whole bunch of text describing when you should pick it, and it gets kind of silly. But it worked really well out the box in terms of like just with no massaging, just running the data through it. We hit 75% correct article choice, and human beings are only hitting about 81%. So the delta between us and a person who's good at this isn't so big, and providing that we capture like the rules and the topics really well. And at this point, we went back to RAG. So we took this thing and we broke it, and we basically broke it into all these little documents, and we embed this as separate little RAG guys. So now that, how do I make sure my national insurance is up to date is going to be somewhere nearby the correct article, because we give a list of all the kind of topics that you should be choosing the article for. So our vector store doesn't have our actual articles in it. We have two different databases, a database that's got the rules for the AI, and that runs through a vector store. And we've got a different database that is just an ordinary relational database, and we look up the article based on the ID number. So it's a sort of random little way we solved that problem, and it's working pretty well in practice. This is what the actual prompts look like. It's the same basic prompt as that ginormous one from a moment ago. This is the boilerplate for every single one. At the bottom is the user's question, but there's only 6 candidate articles here instead of having like dozens and dozens, which that crazy prompt had. And that's the way we found the RAG to be beneficial. Is reducing the possibility space of the selection criteria. The design has evolved a fair bit since then. We now clean up all the PII, the personally identifiable information on the way in. We have multiple different LLMs used for different purposes. We try to identify sub-questions, and we try to make sure we also say, this is the reason that we thought this would be your answer. Because we can't say, you asked about, and just say it, because we can't generate. So we now have this long list of hundreds and hundreds of different types of questions. So we pick the closest type of question as well as picking the answer. It's evolved, right? But that one idea is the core idea behind the whole thing. So that's the second takeaway. Consider how the embedding model is going to understand your data, and how the LLM is going to understand your data, and figure out, how all these things different connect, right? Specific embedding representation decisions really depend deeply on your use case. And that the ETL process of hydrating your data store is always important. And some people started to think it maybe wasn't as important because, LLMs are really good at acting as an API into text. And, IBM reckon that like 80% of all data is unstructured text, right? But that doesn't mean that you don't have to think about your underlying data representations. And that last thing I told you, I actually stole from James, who's sitting back there. Not James, sorry, Sam, who's sitting back there. James Bentley, it's Sam James. And another thing about this, the way your data is represented, like a couple of weeks ago, I was at a talk, another RAG talk, but I think his name was Vance. He was talking about how like tables are a nightmare to embed, because if you were to chunk a table up, the numbers don't have any meaning. So like it's really challenging. LLMs understand tables best if they're in Markdown sometimes. The embedding store understands it if you extract all the data and write it in a summary form for the table. Like none of this stuff is easy if you're doing it at a production level. It's all trivial to do in the 8-minute YouTube demo. Anyway, that's the talk. We'd happy to take any questions. Yeah.
Right, Brian, for data